Welcome back, everybody. Today, we're going to jump in and possibly finish, we'll see, a new section. So only 4 sections in our chapter, and 2.3 is where we're at right now. Okay, 2.3. All that we're really focusing on throughout this is a couple different varieties of the same question. Angles in and with, so I'm just going to say and, triangles. Okay, there's some things in here that are going to be like super duper obvious, some things that will be less obvious, but I think that in this section specifically, there's nothing wild that comes out. Right off the bat, I'm not going to write it down, but it's called a triangle because it has how many angles? 3. Try of them. Okay, so easy, knocked out. We are going to see 2 different theorems, and we're going to introduce them right off the bat. And this one, I'm going to leave it blank for now because it's going to be the same as one of our theorems. Okay, when we're looking at triangles and their angles, there's really only 2 possibilities. They're either going to be the interior angles or they're going to be the exterior angles. So let's focus, at least first, on these interior angles. And I'm writing it as a vocab. I don't know that I really need to, but we'll make sure that we have it. If I draw a triangle, and I think we're going to be able to get by with just this. Do you guys see the 3 interior angles of this triangle? Yes. Okay. Can we say that they're 1, 2, and 3? Yes. Do we need a definition other than saying these are interior? Everybody agree that these 3 angles right here, angle 1, angle 2, and angle 3, are what we consider the interior angles? Yes. Okay. I'm not going to say any more about that then. The 3 angles on the interior of a triangle are known as the interior angles. There's nothing crazy about it. They're inside. Okay. If we can all agree that that's true, the rest of this is going to be pretty chill. This first theorem, we get 2 right off the bat. We're going to prove one of them. But the first theorem feels odd, like why would it fit in here? But I promise there's a reason to it. So right off the bat, we are going to introduce a new theorem. And there's a lot of them. I'm open to the idea of having a running list of theorems. I haven't taken the time to do it yet, and giving like printouts and stuff if you'd rather use that than a note card. If you just want every theorem that we've seen, but the list is going to get huge. Okay, theorem 2.10 is our first. It doesn't have a name. And you guys love all this fancy shorthand or you hate all this fancy shorthand? Okay, so here we go. We'll write it in the fancy language if you'd like, and we'll see something pretty handy about it. Given a line and a point not on the line. And I'm going to start drawing this simultaneously. I have one more little statement to make here, but right now, here's where we're at. I have a line and a point. That's it. Okay, if I give you this line and a point that's not on it, just like this, then we're going to say that there exists a unique line through the point parallel to the first line. Okay, just to show what this means, because it feels kind of blah when you read it. I give you a line and a point that wasn't on the line. All I'm claiming, yes sir. All I'm claiming is that if I said, let's draw a line parallel to that black line through that point that we added, there's only one line that we could ever possibly draw. Now, I'm not going to take the time to do the compass and straight edge, but can we all agree that there does exist a line that is parallel to the black one that runs through here? Yeah. Like, we're just going to say whatever I draw is the parallel line with the understanding that it could be constructed. So here we go. I think that it's this one. And does that look parallel enough to stop there? You say no. Why no? Like, and I'm legitimately asking. That doesn't look parallel to you? Better? Yeah. Okay. So here's what this theorem is saying, and it's going to be obvious when we actually think about it, but it's claiming that this line is completely unique. Means there's only one possible line, and we would all draw the same line. to demonstrate that, here I am. I'm going to draw the same line again in a different color. And you tell me if they're the same line or different lines. Okay, so it has to go through this point. It has to be parallel, right? Did I draw a different line or did I just go over the exact same line? And if I went over all the same points, is it like it's a different color, but is it really a different line? No, it's the same line, just a different color. This is a unique line. Only one of them that does it. That's all this theorem says. Okay, that's the whole theorem there. That's it. If you give me a line and a point, there's only one line through that point parallel to the first line. Only one line. Okay, now you might look at that and it doesn't seem super hard to believe, I don't think. We're not going to prove this one. We are, however, going to prove the next one, and we'll see where that sigma shows up. Before we go any further, any questions about this first theorem? Okay, deal. So here's the theorem that we're going to prove as well then, and I'm going to switch colors. When you hear triangle angles, what color comes to mind, Riley? What color is a triangle? Okay, deal. So here we go. Theorem 2.11. This one does get a name. It's important. Okay. Have you ever seen me shorthand stuff because I don't like to write?
Yes.
Okay. I'm going to shorthand this one. I want you to shorthand this one. Everybody should shorthand this one. This is called the triangle angle sum theorem. Check it out. Let's get crazy. I need to take attendance still. What's the shorthand for triangle, do you think?
Triangle.
I'm going to draw a triangle. This is a triangle. The triangle. Do you guys know a shorthand for angle? It's an angle. I don't care if you put the arc across it or not. It is entirely up to you. But I would caution, if you don't put this arc, it looks like an inequality. And if it looks like an inequality and you treat it like an inequality, your problems won't be correct. Okay, this is the triangle angle. And then here's our new one. We saw several Greek letters right at the start of class. The word sum is pretty short. 3 letters. That's it. You can write the word sum if you want. But because there's no ambiguity if we write this in mathematics, we're going to use the Greek letter sigma. It means to sum, to add stuff up. What did the Greek letter sigma look like earlier?
It looks like an E.
Okay, it looks like an E. Now, yours can look like this. That's fine. When I do it, I don't want you to do it like this. That's the wrong E. Make it the goofy one. When I do it, I spend a little bit more time. I do a little up kick over like this. This is triangle, angle, sum. Okay. Now, this one, I'm going to ask you guys to draw a picture. We're going to talk about it right here. I'm going to knock out my attendance because I'm sure I've already got an email saying to do that. If I were to draw a triangle and I looked at all the 3 interior angles, what would they add up to?
180.
So if I am given a triangle, then the interior angles sum up or add up to what number?
180.
Write that down. That's our theorem. We'll draw a picture of it together. If, or given a triangle, if you don't want the word if, given a triangle, the 3 interior angles add to 180 degrees. Given a triangle, the 3 interior angles add up to 180 degrees. Okay, I'm missing 2 today. One of them is Michelle, and the other is either, yep, we're good. Okay. We're missing 1, I was wrong. Weird, that's the first time that's ever happened. What's the triangle angle sum theorem? Can somebody read it to me?
Given a triangle, the 3 interior angles add up to 180 degrees.
Okay, given a triangle, the 3 interior angles add up to 180 degrees. Now, we could write that as an if-then statement if we wanted. If you, for whatever reason, don't catch that, given a triangle, the 3 interior angles add up to 180. Okay, we just saw a demonstration of that. Really important distinction. Is a demonstration a proof? No. I showed you that it worked with 1 arbitrary triangle, but how many more triangles would I have to try with to be convinced it always works? 3? Infinitely many. Literally every possible triangle that has ever existed I would have to check, and I don't have time to do that. So the good news is we don't need time to do that. We're going to prove this. we're going to see something on this proof that you will never be expected to do alone. I'm sorry. We're going to add something extra to it. If we ever need a proof where this happens, where I have to add something more to the picture, I will always help you through it. I'm not going to expect you guys to do it all by yourself. Okay, so if I want to write this proof, I want a picture to deal with. What picture should I draw? So I'm going to draw a triangle. Cool. Does it matter what a triangle looks like? No. So I'm leaving this blank because I'm going to show statement here, but let's think this out. So here's a triangle, I think. Don't care what kind of triangle it is. Does it have 3 angles? Okay, it's a triangle. To make sure we are all thinking about the exact same angles all the time. I don't know what you want to name these triangles. Or angles, rather. We could name it like A, B, and C, which I think is natural for the points. But I'll tell you right now, we're going to add another line. So even if we call this A, B, and C, I'm going to number these angles too, because we're going to add some extras. I think we can probably forego triangle within the points. Let's just number these angles. Henning, where's angle 1? Is it the top, the bottom right, or the bottom left? Over here? Okay. 1, 2, and 3. And I lied, it's going to bug me, but I'm going to write A, B, and C very specifically. I'm going to write A, B, and C. Okay, I have a triangle on the board. It looks good. ABC, or CAD. That probably makes more sense. That's more wordy. All right. For this proof of the previous theorem, I need to show that what happens in this triangle.
They all add up to 180.
Now you say they all add up. What are they?
The angles.
Okay, check this out. I want your guys' feedback on this because I know what I want to do and I know what third hour wanted to do. We could write show that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. We all agree with that. What are your thoughts on this? What if I do this instead? Show the measure of angle 1 plus 2 plus 3. It's a time saver, but if it doesn't make sense to everybody, then I don't want to use it. I'm essentially just treating it like this is going to distribute, right? The measure, instead of writing measure of angle 3 times, is it clear that it's connected to these 3?
Yes.
Anybody, you don't have to like broadcast it in front of everybody. If you would like to use this notation, you can use it. Is there anybody who says, I hate it, I don't want to use it, will you write the other one? You will not offend me, I don't really care. Last chance, speak now or forever hold your peace. Everybody's cool with this notation?
Yeah.
I would suggest you use it. It's going to save you a little bit of time, a lot of times. Okay. Measure of angle 1 plus, it's like I distribute. Measure of angle 1 plus a measure of angle 2 plus a measure of angle 3. Okay. That's what we're trying to show. Okay, so what then? How do, I can't cut that triangle.
Add more lines.
Hey, I'm going to add some more lines. Check it out. This one doesn't even need to be talked about. Can I extend that on the bottom?
Yeah.
Okay, so here's the important part. Did I really change my picture at all? I still have a triangle. Everybody agree with that? Okay, so that one I don't even have to mention. I still have a triangle. Now there's another theorem. If I wanted to draw a line that was parallel to this, there's a lot of them that exist. That black line on the bottom, AB, there's a lot of different lines that it could draw that are parallel. What if, however, I only wanted it to run through point C on the very top? If we all agree we're going to draw the line that's parallel to AB and it passes through point C, if they're really parallel, did we all draw the exact same line?
Yes.
Because no matter what, according to that previous theorem, if we say we want a parallel line through this point, if it's parallel, and we don't even have to like mark it, we don't have to truly draw it, we'll just say here's that unique parallel line. I'm going to add a line to this figure here in just a second, and it's going to happen right there. Okay, so here's what we're given, and this is it. And this is a weird question, and it'll be the weirdest one with it. What were we given?
Angle 1, 2, 3.
So you could say angle 1, 2, and 3. Is that the same thing? Like the numbers are here, that's fine. Do you agree that that's the same thing as saying all I gave you was triangle ABC? Whether you call them angles 1, 2, and 3, or we notice it as triangle ABC with those numbers on it, that's all that we have. Okay, this next step is key. You will never have to do this on your own. But as long as I can add whatever I want to this picture, so long as it doesn't change any of the relationships within. If I wanted to draw this line right here, and I'm just going to say, because it could be done, is it possible that I did this just perfectly so that these are parallel?
Yes.
And again, I just want to stress, if this is the point that we're going through, there's only one possible line that's parallel. That was that previous theorem. I'm going to call this line, I don't care. What do you want me to call it? So why do we get names, everybody? T works for me. Okay, you could call it Bobby if you wanted to. I'm going to call it line T. Now, I've constructed this line, and I didn't really construct it, but I know that one could construct it in a special way. If I say that this is that one unique line, can I just say that, hey, it could be drawn and it looks close enough, that line T is parallel to AB? Like, I know that it exists. There's only one of them that exists. Let's say it's this one. Okay. This was not part of our proof originally. I think that, again, I just want to stress, you will never have to do this on your own, but I'm allowed to do it. I still have the same triangle. Nothing's different. This is called an auxiliary line. Any line or addition that I make that just adds to my picture without actually changing it is called auxiliary. Right, Flying? Cool. All right. When I added these lines, whether it's the extension on the bottom or that top red one, did I give us some more angles?
Yes.
Okay. Because there's more angles that maybe we'll wind up using, because I don't know, I think that maybe, just maybe, we've dealt with some parallel lines these last couple days. Let's number these angles and make sure that they match. You're good. You don't. Okay. First thing. Is there a way that I could mark that these were parallel? Okay, the second I write it, I'm going to do it. Cool. Let's name some more angles. What angle is this? It can't be 1 or 2 or 3. Can't be Bobby either, just for the record. I'm probably going to use numbers. 4 is a natural choice. 5, 6, and 7. All right. Did adding these angles change anything about my original picture? No. Okay. Right now, I know that we need to wind up here. Have we ever mentioned angle 1 or 2 or 3 in this proof? No. Is there any nice angle relationship anywhere up here that you guarantee without a doubt is true? I'm going to give you like 30 seconds. There's probably a bunch of stuff that you recognize. 30 seconds, chat with your neighbors, something that is undeniably true about any of the angles up here. 30 seconds from now, talk quietly with your neighbors. Go, you're good. My face also needs splashed off, so do that too. If I had mine, I would go into it.
Why do I have 2 parts? 6 and 3.
This is the truth.
I know that 3 is 7.
You can't do any of that. What is 6 and 3? Yeah, I agree. Yeah, that's true.
It goes 1, 2, and 3. Do you hold up Riley's glasses to prevent him from going like this?
These bad boys. I'll bring you.
I told you.
Oh, for real? Yeah, I am a constant. Yeah.
Wait, can't you just do these?
I'm afraid to bend them because if my glasses break, then I'm going to be lazy-eyed for until they're fixed.
It is normal to have a lazy eye.
Do you have one too?
I have a bad lazy eye.
There's a crazy concentration of people that I've seen in this building with lazy eyes. It is insane. Have you guys noticed mine yet?
No.
Oh, mine might be lazier than yours. Have you guys never noticed it? Okay. Let's finish this proof, and then we'll talk about my lazy eye. Because me, Mr. Baker, Miss Carr, if you remember her, had a lazy eye. Apparently Prime does. I've never noticed Prime's. The lazy eyes are going to rule the world someday. It's going to happen. Okay, so. Hey, I like it. All right, so coming back together. Let's check it out. If you never know what to do in a proof, there's always a piece of advice that I give you. Try to find a way to write any of the stuff that you need in it. And then you guys, I heard a bunch of good ideas. I have parallel lines, and we saw some relationships between angles and lines throughout these last few days. Give me an angle that guaranteed is the same as 5. Why? Alternate interior. Now, what I see people do over and over is somebody will try to say 5 is the same as 3 and alternate interior. I get where you're coming from. Unfortunately, you're wrong, but I totally understand where you're coming from. When we deal with these theorems, parallel lines cut by a transversal. If I wanted to be something to be parallel to 3, do we all agree that this is the transversal that it's used?
Yeah.
So I cover up this one. Don't look at the other one. It has no bearing on that particular transversal. From once we do that, what's the same as angle 6?
3.
So just pause here. You just told me that 3 was the same as 6 and 1 was the same as 5.
Yes.
What? Okay, Prime said they all equal 180. What do you mean? Because we can't say that they equal 180, therefore the proof is true. Something is 180 here. More than just a triangle, which is what we're trying to prove. 5 and 2 and 6. It's a triple, not a pair. When you put 5 and 2 and 6 together, they form this red thing. It's a line. It's a linear triple. What do I know that measure of angle 2 plus 5 plus 6 has to be? Okay, so let's do that first. And I will write them all out. You guys can use the shorthand if you want. Measure of angle 5 plus a measure of angle 2 plus a measure of angle 6 is 180 degrees. I agree with that statement. How did we know that? Linear triple. If you called it a pair, do you think I'm going to take points from you?
Yeah.
I appreciate that, but no, I probably wouldn't, just so you know. I can tell you're trying to use the right idea, but I have the fear in you, which I like. Okay. Well, I have angle 2 in my proof now, but I don't have 1 or 3. Good. We can't use substitution yet because we haven't written anything to substitute. However, I do agree that angle 5 is congruent to angle 1, or if you'd rather, that the measure of angle 5 is equal to the measure of angle 1, and there's another pair that I could use. Angle 3, or 6, is congruent to 3. The order doesn't matter, I just changed it so it's consistent. On either one of these, whether it's 5 is the same as 1 or 6 is the same as 3, how do I know that?
Opposite.
So alternate. But if you wrote opposite, I would take it. Alternate interior angle. And it's really a theorem, but I'm just going to shorthand it there. Okay. Now, can I do my substitution? Instead of angle 5 right here, I'm going to rewrite this line, but I'm going to do it a little differently. Instead of angle 5, what can I write?
1.
So we're going to replace angle 5 with 1, because we can, and I see that we can. So I get the measure of angle 1 instead. Plus, do I need to replace this one? No, he cool. We need angle 2. What could I replace this 6 with? And when I straight up replace, because we see they're the same, what do these have to add up to? And check it out. We just substituted. Quod erat demonstrandum. Meaning what?
Done.
Done. That which was to be demonstrated, or done. It's a box with a square. I don't know why that's how I always say it. In my head, box with a square. Cool. Yep, don't know why I say it. I've said it for 30, 40 years at this point. Don't know why. Cool.
So I thought that was the actual.
Nope, it's a filled in box. I call it a box with a square. Okay, looking at this. If I had given you this line to begin with and labeled everything, whether, do you think you would have gotten here? Maybe. Would you have gotten at least somewhere?
Yeah.
Okay. When we have this line, which is not immediately clear that you need to add it, can everybody, let me rephrase this. Is there anybody who didn't understand what I did at any step and now we're 5 minutes later and I'm going to ask now? Where'd I lose you?
Wait, what are you asking me?
Is there any part of this that you did not understand why we wrote it or why we knew it?
I just don't understand.
Line B? So this one is unique. I did this to make sure that we had this line so we could prove it. The actual theorem, if you had to prove it, this wouldn't be given. I had to help with this one.
So if you need to solve it like this on the quiz, will be back to me?
I will not give you something where you have to add a new line to solve, ever. Okay. This theorem, now it's true for how many triangles? All of them. Not just a single one that I cut the example of, but every single possible triangle. It doesn't matter how we draw the first one. Okay. This theorem.
Does that mean if the
Nope, we just proved it. So it's not just accepted as true, which is why we had to do the proof. Whenever you prove something, you're proving it for all of that case. All right, let's see how this works. We need to make sure we can use not only the proof of the theorem, but we need to be able to use the theorem. I want you guys to try one together. We'll come back together either when you're done or when we reach a point where we realize people need more help. But I want you guys to try one first, working with your peers, rather than me just saying, here's how we do it. Cool. So, example. We're going to call this use. And what did I just write? Use what?
Angle sum.
Use triangle angle sum. Okay, so here we go. Let's get a lovely picture. I'm going to draw mine obnoxiously large with the understanding that it's just so everybody can see it. Okay, on A, and we'll do B if we need, and we definitely will do B. You do not have to draw it this big, but I am going to label some stuff inside, so it's up to you how large you want to draw it. Okay, here's how big we need it. I want this angle in the very bottom left to be 77 degrees. I want the angle in the bottom right to be X degrees. We're going to get crazy though. I'm going to come up to this point up top, and I'm going to drop a line down somewhere. And you guys prefer it a little bit to scale, so I'll put it about right there. I look at see who's writing because inevitably I'm going to start writing and I'm going to say something and then somebody go, what did you do? In about 30 seconds. So I just try to preface that. Yes. I wore a helmet when I rode my four-wheeler. Henning?
Well, I normally do. I just don't.
Sure.
Well, my dad makes me.
Good. I don't know how much the ticket is if you don't, but
Actually, I don't think you have to have.
guarantee if you're under 18. Anyway,
Well,
I'll look up the code for you.
I don't even have my license sometimes.
That's doubly illegal. 35 degrees right here.
Just trying to get a risk. No, why would you have to do that?
All right. Everybody have a big triangle with a line drawn through it.
Yes.
How many triangles did I draw on the board?
Three. Three.
I heard two, I heard three. Who's right?
Three.
Right.
Two.
It's
Three.
three.
Wait,
Yeah.
don't tell me. Actually, I don't know.
Oh, 1,
The
2,
big
and
one
3.
and the
Left,
middle.
right,
Yeah.
big. We have three triangles on the board. Left triangle, right triangle, big triangle.
I was gonna say.
All right. So, two more little things, and then I'm going to cut you guys loose for a minute. Just kidding. One more little thing. This is y degrees right here. It's not congruent to anything, but I'm going to put this arc just so it's really clear what is the angle that's y degrees. Cool. Your challenge here, what I want you to get to, is I want you guys working with your neighbors for a moment. You're going to find me the values of x and y. I'm going to give you a head start. If you get an answer, awesome, but you also need to be able to explain it to me because I'm going to ask if you get a quick answer. This is not a proof. This is not a proof. Nope. The only time that you'll ever know it's a proof is you will see me very specifically show this, and I will write that every time. Cool. All right. I'm going to give you guys a couple-minute head start. If you're doing stuff on the calculator and you get an answer, but you have no work written, I'm going to make you write your work before I tell you whether it's right or not. Cool. Couple minutes, we'll come back together. Go. If we tried to start solving this for y, I'm probably going to use triangle angle sum, right? Okay, 77 degrees plus y plus equals 180.
Yeah.
Notice the awkward pause. I can't write anything. Now, you might know what it is because you're doing a little extra thought, but right now we don't have it. Okay, if this happens on a problem and maybe you don't have that extra thought to clean it up, does it mean that it's broken or should you just try the other thing? Let's try the other thing. If we instead did for x, which is probably more natural for people to do first, is x on the right triangle or the left triangle? How many angles on the right triangle do we have labeled?
Two.
So we have, two of them are known, but all three are labeled, right?
Yeah.
What do we know these three add up to?
180.
So there it is. There's our entry. 35 plus 96 plus x equals 180. How many of you guys did something similar to this? Cool. Okay, so help me out here, or I'll help you out. Is this 131?
Yeah.
131 plus x equals 180 after we just combine our like terms. And now I'm going to subtract 131 from each side, and I think I get 49.
Yeah.
Okay, x is 49. Okay, done. What about y now? Because that didn't give me any of that. Why? Oh, Elijah notices this. And he says, hey, them angles are adjacent, and they form a line. What do they have to add up to? 180. Now, this is not the only way to do it. If you are looking at this and thinking, I would have never thought of that, you're good, because it's not the way that I would do the problem either. But we can get it. I think that this angle has to be 84. I'm going to give you guys a minute. I assume that you're going to use the left triangle to solve for y. While you're doing that, I'm going to use a different triangle. I'll even change color. I'm going to look somewhere else on this picture and see if we get the same answer. You use left triangle. I'll use a different place. You're going to use these three, and you know they add up to what? Okay, solve that for me. I'm going to do it differently.
Did you already get what?
Sophia,
No, you're good.
what is,
That's what you did?
77
I like it.
7 plus 84. 77.
Wait, is it
1 how much?
is one?
Yeah, but where
I think so.
did you get 84 from? Yeah, that one.
These two, what do they have to add up to, Sevilla? They form a straight line. Good. 96 plus unknown is 180. The unknown was 84.
Those two?
Yep, so, because you just told me they add up to a straight line, right? If we don't know this angle, call it R, for example. Like right over the R. Now, in our scratch work, what do you know we get when we do R plus 90? So write that over here, times wherever you want. R plus 96. 180? Can you solve that for R? R is 64, which is what we have. All right. So, checking this out. I'm trying to clean up my work here. And let me check. 161. Is that right? 77 and 49 and 35. Plus y equals 180. Okay. I'm doing something different than you. And I just got y is 19. What did you guys get?
19.
Huh. What did we do different?
You added 35, we didn't.
Oh, never mind.
So why did I have to use something different?
Because you didn't use 84.
You guys did 77 and 84 and y, right? Okay, you chose the left triangle. I told you to use the left triangle. I'm good with that. What did I use?
You used
I used the big triangle and the fact that we already knew x, and these three angles together should also add up to 180. It doesn't matter which one we viewed. We all got the same answer. The triangle angle sum doesn't care what triangle you use as long as you're looking at the three angles that make a triangle. Cool. Feels okay? Feels awful. All right. 5 says, this is awesome. I'm so good at this. Bring them on. 0 says, please don't ever make me do something like this. I don't get it. Where would you put yourself? All right. So a lot of 2.5s or higher. Prove it.
Wait, what was the big one? Oh, wait, what was?
5 is good. 5 is you're good. Okay. You are inevitably going to hear me talk about bow ties in here. It's going to happen. Not that I'm like well dressed. I don't own a single bow tie. But do you guys know what a bow tie looks like?
Yes.
Okay. This figure that we're going to draw here shows up all over the place in geometry. Does that look like a bow tie to you? Cool. I've also heard envelope or envelope. Can anybody see the envelope here?
Yeah.
But where's the line?
You, yep. Cool. I actually refer to these as bow ties and butterflies. I don't care which one. Okay. So, here we go. A little editing magic so the video is less lengthy. I'm going to put some angles in. For this problem, I want you guys to work through it. I'll come around. I don't think I'm going to put work on the board. I'm going to put the answers on the board, which means it is your job to either ask me for help if you're struggling with the work or to ask your neighbors for help. Really important. Is helping just giving the answer? Not even a little bit. Helping means coming to an understanding. I will give you guys a couple minutes. I'll be walking around. If you're struggling, I want to help, but I'm not going to like sit down and make you ask for help. You have to ask me. Cool. Truth, we're going to not show work. I'm just going to say ... Look at that. Some stuff happens.
Wow. 3?
X is
64.
64. Y is
74.
74.
Yeah.
I heard a good question. Somebody said, do you say degrees? This one's kind of unclear. Realistically, I don't think so. X is just representative of an angle or a variable, right? It's included here. If I had said find the measure of angle something, then definitely need degrees. This one, I don't really think we need it, but because it's all that's labeled there, I'm going to include it. If you struggled with this, how do we get 64? I'm not going to show all the work, just walk me through it.
7 plus 59.
These three angles together add up to 180. If that's 64, what's this?
64.
Why?
Because they're vertical.
They're vertical angles, and now you have all three on the other one. Okay. We have 6 more minutes. Yes, I will talk about lazy eyes. You guys have never seen my lazy eye. You've never noticed it.